All right, hello everyone. So we're gonna go forward with our chi-square test of association to see how much evidence there is for whether the race variable and getting a callback in this experimental study are associated. And so our chi-square statistic is the same exact thing as what it was for the chi-square goodness of fit. Um, We're not deriving this again because this isn't theoretical stats. This is applied statistics, but we still want to make some kind of sense about what this chi-square statistic is doing. And so if you kind of notice in this formula, we're doing the observed count minus what's expected under the null hypothesis, squaring that for each cell, and then adding them all up. And so there's a little typo on there. There's a 14 that should be a 4. And so the logic is that if the expected counts were computed assuming that that null hypothesis is true, then if the alternative actually is true and there is an association, then the observed counts would be super different than what we would expect under the null hypothesis. So that logic should kind of make some intuitive sense. If that's true, then larger values of this chi-square stat are going to indicate that there's more evidence for the alternative hypothesis. And so let's go ahead and calculate this chi-square statistic for this example. And so again, this is the part that if you've set it up right, this is what I think is the easiest part. It's the setup that's the hard part. And so I'm just going to go the first observed count minus what's expected under the null hypothesis, square that, divide by what's expected, and then we're just repeating that for each of the 4 cells. And so then we've got, I'll go down first. All right, so that's this bottom left cell, then I'll go up. And then finish off with this bottom right cell. So if you add all those up, you should wind up with a 16.9 as our chi-square stat. Just like what we did before with the goodness of fit, the shape of this chi-square distribution, assuming that the null hypothesis is true, is going to depend on the degrees of freedom. And so the degrees of freedom for a chi-square test of association is just the number of categories of the first variable minus 1 times the number of categories of the second variable minus 1. And so for this example, the degrees of freedom are just 1. Unlike the normal distribution, we mentioned before that this chi-square distribution, you really kind of have a hard time drawing it without stat key. And so to actually look at what the distribution shape is, you'd have to go on to stat key and enter in the 1 degree of freedom, and you would kind of see that the shape looks something like this. And so again, using stat key, you could enter in what our observed chi-square value is, which is 16.9. And remember, since larger values of this chi-square stat are more in favor of the alternative hypothesis, the area that we're shading is to the right of our observed chi-square statistic. And so the area that's shaded is our p-value. As you can see, it's barely any area, and so when you actually plug this into stat key, you would expect a really small p-value, which is what you get. And so the p-value for this problem is 0.00039. And so based on this p-value, using our scale of evidence, then that means that what we found is convincing or strong evidence. Using our kind of format for reporting conclusions, we just want to state what the alternative hypothesis is in context of the problem. And so we found strong evidence that there is an association between race and receiving a callback. Just like what we did for the chi-square goodness of fit test, we could also look at the contributions of each cell, which I wrote out here. And so they're 0.679, 0.679, 7.76, 7.76. And so we could put these in a little table. And then it seems kind of silly for this example because there's only two categories of each, but these relate to our conclusion because we can see from these expected counts or from these contributions that race and callback are associated because these two contributions are really quite large. And so because in general, white applicants received a callback more often than black applicants did. Okay, and so this is a very serious study, and to me this is not necessarily surprising, but a very disappointing, I guess, result that there's this strong of evidence for basically discrimination in calling back these applicants. And so there's some notes here that we'll talk about in a second, but we want to make note that this was an experiment. Because there was random assignment of names to resumes, because there was this random assignment, what that means is all other possible confounding variables were really balanced out between black and white applicants. So things like experience, or maybe the way the resume looked, or education, or anything like that, all that stuff gets balanced out when we randomly assign the names to the resumes. And so this does allow us to conclude a causative effect. So we can say not just that race and receiving a callback were associated, we can say that race is actually a causative effect of whether or not an applicant receives a callback, which is a much, much stronger conclusion than just saying that the two variables are associated. This question, though, take a second to go ahead and pause the video and think about that. So can you conclude that a particular employer who participated in the study racially discriminated? And so the answer to this is probably not. It depends on how many resumes each particular employer evaluated. But if each particular employer only evaluated maybe one or two resumes, it'd be hard to make that jump based on just one or two observations per employer. So no, if each employer only evaluated a couple of resumes. All right, so we'll come back to this example in one last kind of short video to talk about some of the implications of this study.